Yo guys, welcome back to the channel. My name is Shabir Safi, and in this video we are going to understand and install log aggregation system on our local Kubernetes cluster. So let's get to it. Let's understand log aggregation at a high level. Let's say we have two different applications distributed across multiple nodes, and each of these applications are generating different types of logs. So we need a process to aggregate these logs in a meaningful way. To do that, we need a central location that is a logging backend where the logs can be stored, analyzed, and correlated. On top of that, we need visual interface tools like Kibana that allows us to explore, visualize, and build dashboards over the log data that we have collected. So now to extract these logs, we need an agent installed on the host that collects and sends the log data to the central server. For Elk Stack, there are several agents that can do this job, like Filebeat, FluentD, and Logstash. You'll often hear these terms like Elk Stack or EFK Stack, which is just a collection of these tools to implement log aggregation. Now that we have a base understanding of log aggregation, let's implement this in our cluster. Before we go ahead and deploy a bunch of stuff, open your Docker preferences and open Resources tab, and make sure you have enough resources allocated to your Docker. Okay, first let's go ahead and create a new cluster. You can find the Git repository link in the description, which contains the script to bootstrap the cluster. I have also posted a video previously that walks you through the process of creating a new cluster. Okay, let's quickly verify that we have a new cluster created. And let's also make sure all of our nodes are in the ready state. Great. The next thing we'll install is Helm using Homebrew. For those who don't know what Helm is, it's a package manager that installs Kubernetes applications. Think of it like apt or yum or Homebrew, but for Kubernetes. Helm uses packaging format called charts. A chart is a collection of Kubernetes manifest files along with some other files that describe an application. To install the components for our log aggregation stack, we are going to add this Helm repository, which provides us with various Helm charts that we need to install. If we go to the GitHub for this Helm repository, we can see all the different Helm charts that they have available, like Elasticsearch, Filebeat, Kibana, etc. So let's click into Elasticsearch, and you'll see a values.yaml file that provides the default values to the application. Anytime you are deploying a Helm chart, I would highly recommend that you browse through these value files, because very often you may have to override some of these values. For instance, this chart generates a random password for Elasticsearch by default. But to make things easier for us, we are going to override this and use our own password. Another thing we are going to override is the resources block, because we are deploying it in a local cluster, so our resources are limited. Okay, so we need to create this values file for Elasticsearch, where we are overriding few values like resources and the capacity of the persistent volume, and as I mentioned before, the password to access Elasticsearch. Okay, let's go ahead and deploy the Elasticsearch Helm chart. The create namespace flag will create a new namespace logging if it does not exist. And we also need to pass the values file that we have created. Okay, looks like the Helm chart is deployed. Let's watch for the pods to be ready. It will take around 2 to 3 minutes for Elasticsearch pod to be in the ready state, so just wait for it. Okay, Looks like the pod is ready. So let's take a quick look at all the pods in the logging namespace. Everything looks good. Let's move on. The next component we are going to install is Kibana. And just like for Elasticsearch, we have a values.yaml file, and we are going to override the resources section. If you need to search any Helm chart on your machine, you can do so with Helm search repo command. And as you can see, we have Kibana available. So let's go ahead and Helm install it. And don't forget to provide the values.yaml file and also the namespace. Okay, the Helm chart is deployed, and just like before, let's wait for the pods to be ready. And it will take about a minute or so for Kibana pod to be ready. Okay, let's take a look at the pods and services deployed to the logging namespace. See, we have a service deployed for Kibana at port 5601. Now, to access Kibana dashboard, we are going to use port forwarding. When we are developing applications on Kubernetes, it is very useful sometimes to quickly access a service from your local machine without exposing it using a load balancer or an ingress object. And in those cases, port forwarding is very handy. Okay, so let's go ahead and run kubectl port forward command and provide the name of the service and the port number. Let's copy this and open up our browser. And we can access the Kibana dashboard. So let's log in using username and password as Elastic. So now, if we navigate to the Discover tab, it tells us that currently we do not have any data in Elasticsearch. And that's because we have not deployed our agent on the nodes to collect and stream the data to the Elasticsearch. Today, we are going to deploy Filebeat as our agent. So let's go ahead and Helm install the chart. And just like before, let's wait for the pods to be ready. Great. So now if we go back to our browser and refresh, we have the data in Elasticsearch. And all we need to do is add the data view so we can monitor and analyze the logs. In the index pattern, just copy Filebeat and don't forget to add asterisk and give it a name and save. So now we can see all these logs that are collected in Elasticsearch. So let's go ahead and deploy a very simple application that generates some logs for us. Here, I have a very simple pod definition. Is just a busybox container that is just generating some logs for us. So let's go ahead and run the pod. And if we check the logs, okay, so hopefully these logs are also collected in Elasticsearch. So let's take a look. And there we have it. We have deployed a full log aggregation stack on our cluster. In the Git repository, I'll also provide the script that will deploy all these components for you. But first couple of times, I'd recommend that you do it yourself so you understand the process, and also experiment with some other tools. For example, try to deploy a Fluent Bit or Fluent D instead of Filebeat. One last thing, if you are wondering where to find the Helm charts for various applications, you can go to artifacthub.io and search for any application that you want to deploy as a Helm chart. And you can select any one of them. And you can also view the default values that are supplied to the chart. Alright guys, that's it for today. I hope you found this video useful or learned something new. If so, please hit the like button and I'll see you next time.